Okay, so today we're going to look at applications of exponential functions. This is lesson 5.3 of our Precalculus book. And we're going to look at first compounding interest. So when interest is paid on a balance that includes interest accumulated from the previous time period is called compound interest. And so we're going to look at, first of all, annually, and then what happens when we compound interest more often than that. So we're going to look at monthly, yearly, daily, and then in another example later on, we'll actually be looking at what happens when we compound it continuously. So here we're going to do this first example, compounding interest annually. And so we're actually going to use this formula down here. Oops, hey, there it is right there. This formula down here, A equals P times 1 plus R raised to the power of T, where P is our principal amount that we start with. R is our interest rate, and T would be the amount of time or the amount of time periods we're going to use. So for this problem here, we're just going to go ahead and do A will equal 6,000 and times 1 plus 0.08 because we have 8% interest, and calculate that for 10 years. So we go to our calculator and put in 6,000 and times 1.08, because if we add 1 and 0.8 and raise that to the power of 10, we'll get $12,953.55. So I would hope that take my value here and plug it in. Where'd it go? I don't know. All right, let's try that again. Okay. Smart view. Here. There we go. All right. So we have approximately $12,953.55. Okay, now we're going to look at what happens if we compound it with different periods of time. So we're actually going to use the formula then. We're going to slightly change this formula so that it says A equals P times 1 plus, and we're going to put R over N, where N stands for the number of time periods a year. And then we're going to put NT here, where when I multiply N times T, I'll get the actual number of time periods it's going to happen for. So we've got this, we're going to use example 2 here. Determine the amount that a $4,000 investment over 3 years at an annual interest rate of 6.4% is worth for each compounding period. So what we do then is we're going to start out with annually. So we'll say A equals 4,000 times 1 plus 0.064 raised to the third power, because it's for 3 years. And that would be if we're doing it annually. If we're doing it quarterly, then we will say that A equals 4,000 times 1 plus 0.064 divided by 4, because it's 4 times a year, and then raised to the power of 4 times 3 for quarterly. If it's monthly, then we have A equals 4,000. And since monthly would be 12 times a year, we'll put in 12 for N, and then 12 times 3 here. And then last of all, we'll look at it as daily. So we have A equals 4,000 times 1 plus 0.064 divided by 365 days in a year. And then that would be 365 times 3. So when you're figuring those, if it's monthly, that's 4 times a year, or 12 times a year. If it's quarterly, 4 times a year, and daily, 365 times a year. So we're just going to figure out the value in each of those cases. So actually, let's go ahead and do this for each one of them. And let's notice or pay attention to how the value changes as we do more times per year. So we have 4,000 times 1.064 raised to the power of 3. There's our annual amount. And so let's go ahead and take a picture of that. So our annual amount goes here. And let's look at it quarterly. So we're going to change this to 4,000 times 1 plus 0.064 divided by 4. All right, we're going to raise that to the power of 12, 4 times 3. And so we'll get this amount here, $4,839.32. So we'll go ahead and move that one down here for quarterly. And let's do our monthly. So 4,000 times 1 plus 0.064 divided by 12, because we're doing 12 times a year for monthly. And raise that to the power of 12 times 3 is 36. And that gives us $4,844.21. And notice here that so far, we've got 4,818, 4,839, 4,844. So as my number of times per year increases, the value is increasing. And so let's do the last one. 4,000 times 1 plus 0.064 divided by 365. And we'll raise that to the power. Now we're going to put this in parentheses, this exponent, because I don't know what 365 times 3 is, so I'm actually going to type that in. So, but make sure you have it in parentheses, and we get $4,846, and you can see that this is the most. So the more times I do it per year, the more money I'm going to make. And so like when we do it, when we go and work on it continuously, we'll see that that's even a greater amount then. So, all right, so we have one more problem here, example 3 we're going to do. And this one is solving for the period of time. So here we have $5,000 invested at 7% annual interest, compounded daily. So we have, there's that 365. When will the investment be worth $6,800? So we want to know, when is it going to be worth $6,800 if I invest $5,000 at 7% interest and daily, so 365 here and 365 here. So our value of n is 365. So let's find this answer. So first of all, we're going to find the value of this 1 plus 0.07 divided by 365, and then raise the 365 power. We're going to find that value first. So let's go ahead and stick that in our calculator. So parentheses 1 plus 0.07 divided by 365, and we're going to raise that to the power of 365. Okay, so we get 1.0725. So 1.0725 here. Now that's going to be to the power of t, and we still have our 5,000 and our 6,800 here. Okay, so we were able to simplify that part there that we highlighted with our smileys. And so now we'll go ahead and put the rest of this into our y equals to find our answer. So we've got 5,000 times 1.0725 raised to the power of t, and 6,800 here. So we're not sure, so let's look at our window. All right, so hopefully we're not sure how many years this will take, but let's check and see if 10 is enough. So let's go from 0 to 10 for a number of years. And then we need to go to at least 6,800 for our y max, so we'll go to 7,000 and do 1,000 for our steps. And graph it. And we can see that there is our intersection. So we do have 10 years was plenty. So second trace, number 5. And we can see that it's 4.39 years. So t is approximately 4.39 years for our $5,000 investment to be worth $6,800.